Thank you so much, Ms. Lee Muyuan. Let's also welcome Wang Jieru from China Meteorological Administration, presenting on the complementary characteristics of wind and solar energy resources in China based on a three-component complementary index.
Hello everyone, glad to share my research on the complementary characteristics of wind and solar energy resources based on a three-component complementary index. As the most potential renewable and clean energy, the development and the utilization of wind and solar energy have attracted the attention of all countries in the world. However, the two renewable resources are intermittent and fluctuating, which cannot be ignored in large-scale grid connection of this renewable energy. Power grid dispatching requires the real-time balance of power supply and demand. Thus, the readiness and intermittency of wind and solar energy resources exert great pressure on power grid dispatching. The complementary or synergy of the two resources will weaken or enhance the total output fluctuation. Therefore, it is necessary to establish a scientific and reasonable complementary index, conduct an evaluation of the wind and solar complementary in different places and at different times, and seek for regions and time periods with better complementary, so as to minimize the volatility of local joint renewable energy output, or meet the local electricity load as much as possible. This study investigated previous studies and proposed a new index based on the work of Belloco, Gilberto, and Li. Belloco proposed a way to evaluate the complementary in time in the same place with the determination of a dimensionless index. He defined the complementary between renewable energy resources, in particular in solar and hydraulic, as the ability of the sources to work in a complementary way. They defined a complementary index, K, as shown in the equation. Gilberto improved the Belloco index to make it more suitable for measuring wind and solar complementary index. Li developed an approach to calculate the complementary index of wind and solar radiation, that is, to twice normalize the wind and solar radiation data and calculate the area between the two time series profiles. Our new index is based on this work, and the calculation method is what I describe next. The times partial index KT is calculated by the area between the two time series profiles, twice normalized. The first normalization is to divide the daily variation curve of the output of the two resources by their respective daily mean, so that the two curves fluctuate around the zero value. The second normalization is to divide by their respective maximum absolute value, so that the fluctuation range of the two resource curves is all fixed between -1 to 1. The energy partial index KE is measures the difference of the total energy of a day. The closer the two total value, KE is more close to 1. The larger the gap, the closer to 0. The same with the amplitude partial index, and which measures the difference of amplitude in the daily variation of resources. When the difference is greater, the index is closer to 0. To consider the practical issues and decrease the influence of the total value of the resources and the amplitude of the amplitude on the final complementary index, we exert adjusting functions as the following shows. In this study, we have obtained ERA5 data covering 1991 to 2020 at 0.25 spatial resolution, and its 100 meters altitude, wind speed, and the horizontal plane total and indirect radiation are extracted. Then wind speed is converted to wind power density, and the total horizontal plane radiation is converted to inclined plane radiation by considering the temperature reduction effect. Use the rated power as a benchmark and transform the data into unit values. And then next to calculate the biological Sievers index as mentioned before. Depicted in the complementary characteristics of wind and solar energy resources of China. The index proposed in this study is compared with the complementary index commonly used in previous works. That is including correlation coefficient of variation, and the duration of shortage of wind and solar. This picture shows 30 years mean values of the three partial index distributed in China. Difference of wind and solar energy, either the total amount or the amplitude difference is most obvious in southwest China. The areas with the best complementary are the western part of northwest China, the northern and southern part of Inner Mongolia, the central and southern part of East China. This picture shows the mean values of complementary indexes distributed in China. In some areas, such as northeast China, Inner Mongolia, and Xinjiang Basin, all indicators agree that complementary is good. But in the central and western regions of Tibet, there are disagreements in the four indexes. Correlation coefficient shows poor complementary. However, the consistency of biological Sievers, the coefficient of variation, and the shortage of wind and solar energy indicates good complementary in this area. We selected the Ningxia and its surrounding areas as the typical area study. The area spans about 400 kilometers from north to south and 300 kilometers from east to west. The blocking of Helan Mountain in the north not only weakens the eastern attack of the northwest alpine air, so the climate difference between the east and the west is quite large. In the following, these daily complementary indexes is averaged by every month in 30 years. Only the biological Sievers index has a high value representing strong complementary, while the other three indexes have a low value representing strong complementary. It can be seen that the monthly changes of the font 3 indices generally show a consistent trend. and the intraday complementary is strong in summer and autumn. The duration of the duration of the shortage of the wind and the solar energy, and the stability is good. The duration of the shortage of wind and solar energy is low, and the stability is good. Similarly, as mentioned before, the correlation coefficient shows less consistency. And thank you for your listening.